Good morning, everyone. So today we look at the solution from the first International Math Olympiad. Okay, so this was held in 1959 in Romania, and it has 6 problems, and I believe it was held over 2 days, so 4.5 hours each day for 3 problems each. So, but I'm not completely sure. Anyway, we just go through the problems and their solutions. So this is problem one. It's actually very easy. You have to show that this fraction is irreducible. Okay, so basically what you have to show is that GCD of these two is 1. So first of all, you just assume that GCD to be G. So one expression is G times N1, this one, and this is G times N2. And after that, you find a linear combination which equals 1. Okay, so that's the trick. And you can see that 3 and minus 2 works. Okay, 3 and minus 2 will cancel this n term, and after that, you only get 1. So now you put the Gn1, Gn2 terms here, and what you see is that product of two numbers is 1. Okay, and G is positive, so G must be 1. So the GCD is 1, and that's what you have to prove. And if you want to learn more about this method, you should check out Euclid's algorithm. Okay, that's where this comes from. So yeah, next problem. This is you have to solve for x for different values of a, and it says that only non-negative real numbers are admitted for square roots. So first of all, the expression inside this square root has to be positive for the whole thing to make sense. So x must be greater than or equal to half. Okay, and after that, of course, the second expression x minus 2x minus 1 also must be positive, but this is anyways true for x greater than or equal to half. So that's fine. And so now we'll start. We can basically we can just square this to simplify it, and you get this, and you have a plus b, a minus b type of term inside the square root here, twice ab. That also you simplify it, and this becomes a perfect square. And since you have to take non-negative real numbers for square roots, so you just take a modulus of that. So modulus of x minus 1 is a square by 2 minus x. So that's what we get. And of course, from here, I think the simplest is just plot the graph. So we just take this as x-axis, this as y-axis, this is 0, 0, and we should take only values x greater than half, greater than or equal to half. So at this point, this is our cutoff. Okay, we don't consider anything on the gray side. So whatever is on this line and on the right side of that, whatever solution we get, that is the one that we need. Okay, so you just put okay, so first of all, just plot mod of x minus 1. So at x equal to 1, this is 0, and then it will go at 45 degrees on both sides. So now when you put root 2, this becomes 1 minus x. So 1 minus x, if you plot, it will remain on this line till here, and then it goes to the other side. So between x equal to 1 by 2 and 1, that's your solution. Okay, so the solution set here is x between half and 1. So when a is 1, so this becomes half, so this whole line will shift half unit downwards. So now you can see there is no intersection, so there is no solution. Okay, so and then you put a equal to 2, so this will become 4 by 2, so that's 2 minus x. So now you have only 1 point as a solution, so that's x equal to 1.5. Okay, you can easily see this from here. So that's your solution, and this problem is also done. So then it says ABC are 3 numbers, and you are given this quadratic equation in cos x, and then it says you find a quadratic in cos 2x where the roots are same as that of original. So we find a quadratic in cos 2x which are same roots of this as this. So I think the easiest thing is that you write all this in terms of cos 2x, and just find a quadratic. What you can also do is you can take the equation as capital A times cos square 2x plus capital B times cos square x plus capital C equals 0, and then you equate the roots and you try to find capital A, capital B, capital C in terms of small abc and so on. But I guess the easiest is just to take this, you take cos 2x as 2 cos square x minus x, so cos x will be plus minus 1 plus cos 2x by 2. So this you just substitute it here. So there will be a square root term here which you keep on one side, and this other things you just bring it to other side and you just square it. So this plus minus terms will become plus, and then you just rearrange, and this is the equation you get, and this is the required equation. And then it says compare the equation in cos x and cos 2x for a equal to 4, b equal to 2, c equal to -1. So then of course this becomes 4 to -1, and what you will see is that this also becomes 4, this becomes 2, and this becomes -1. So basically you have two equations with same coefficients, okay, and one is in cos x, one is in cos 2x, and the roots are also the same. So if you find cos x from here, it will become, it's 1 by 4th plus minus, 1 by 4th and -1 plus minus root 5. So this, I think one of them is 72 degrees, I believe. And if you do a cos 2x, if you find here from here, so this will be 2 cos square x minus 1. So if you do 2 times and square of this and -1, you basically get the same number here. Okay, so that's the special thing about this. Then it says compare. So I'm not really sure what exactly they want to see here, because this is a very subjective term. I mean, you can explore these relations a little bit more, but it says to compare the equations. If you just want to compare the equations, they are just the same, and only x is replaced by 2x, and they have same roots. Okay, so I mean, if you want, you can explore this thing a little bit more. I'm not sure how much, how deep they want you to go into this. Okay, so anyway, so I'll just leave it here. And problem 4, it says construct a right triangle with a given hypotenuse c, and median to the hypotenuse is the geometric mean of the two legs. So whenever you hear of a right triangle, so you know that the hypotenuse will be the diameter of a large circle, and the other vertex will be on the circle. Yeah. So here, since the hypotenuse is c, so if the center is this, then the radius is c by 2, and this median, this will also be the radius, so this is also c by 2. And what is given is that this one, c by 2, is the geometric mean of the other two sides. So c by 2 is square root of AB. And after that, we can look at the height, or we can look at the area of this triangle. So area of the triangle is half base into height. Okay, and it's also equal to half of AB, because this is 90 degrees. So this will be the base, this will be the height, so it's half AB. So you can equate these two things here. So CH, H is the height of this one, that will become AB. From there you can get H equal to C by 4, and now the construction is easy. So you draw a hypotenuse of length C, and after that at a height C by 4 you draw another parallel line, and with this you make a semicircle, and you take any point of intersection and you complete the triangle. Okay, so that's what you have to do. What you can also do is you can find the angles of these two sides. One will be 30, one will be 60. I mean, that's also easy. It's like if this is theta, so you can take c cos theta is b, c sin theta is a, and then you can do c by 2 is equal to a root of c cos theta into c sin theta, and from there you will get theta, and you can finish your construction. So that's also easy. This is problem 5. It says there's a point M in the interior of segment AB. So there's a segment AB, there's a point M, and you complete the squares on the same side of AB. And then it says circles are circumscribed about these squares. So you draw the circles about these squares, and the centers are P and Q. And they intersect at M and also at another point M. N. Okay, so they intersect here and they intersect here on this point N. And then it says let N prime denote the point of intersection of line AF and BC. So AF is this, BC is this. So they will intersect somewhere here. Let's call that point N prime. So okay, so you have to show that N and N prime coincide. You have to show that the straight lines MN pass through a fixed point S, independent of the choice of M. So this line NM, it passes through a fixed point S. Okay, as M moves, there is a fixed point where this line passes through. Okay, and then it says find the locus of midpoint of the segment PQ. So you have PQ, this is the midpoint, you have to find the locus of that. So okay, so this whole thing is looking complicated, so we just go through part by part. So let's go start with part A. You have to show that n and n prime coincide. So this AF and BC, they meet at n primed. Okay, so yeah, so first of all what you do is we just call this whole length as A. Let's call this as x. This will be A minus x. So this length will be x. This length FM will be same as this, so this will be A minus x. Then I call this angle as theta 1, this angle as theta 2. And after that, tan theta 1 will be what? It will be A minus x by x. Tan theta 2 will be x by A minus x. So that's that. And tan theta 1 into tan theta 2 is what? That will be 1. So what does it mean? So it means theta 1 plus theta 2 will be 90 degrees. Okay. Why? Because tan of theta 1 plus theta 2 is tan theta 1 plus tan theta 2 by 1 minus tan theta 1 tan theta 2. So the denominator will go to infinity because tan theta 1 into tan theta 2 will be 1. So it will be 1 minus 1, that will go to infinity. So that means this angle is 90 degrees. So this is 90, this is 90. So, okay, so now since this is 90, what does it mean? So if you look at, yeah, so this is 90, this is 90, we see that. And after that, if I join this line AC, and I draw a circle with AC as diameter, so it will pass through this, it will pass through D, A, and C, and it will also pass through N prime because this is 90 degrees. Okay, so this circle passes through N primed. Similarly, we join this, so this angle is 90 degrees, this angle is 90 degrees here. So if I draw a circle with FB as diameter, it will pass through this, it will pass through this, it will also pass through E, so it will look like this. So this point n primed, it lies on this circle and it lies on this circle also. So n primed is same as the intersection point of the two circles, so n primed is same as n. Okay, so you see this, so that's what we have proved. And now we look at the part 2. It says that it says that you have that line mn, it passed through a fixed point s independent of choice of m. So this angle A and B is 90 degrees. So what is the locus of m? So it will be this semicircle which has AB as diameter. Okay, so as you vary m, this n will move on this semicircle. So you have to show that this line nm has a fixed point. Okay, so to see this, so suppose n is on top of this, then m will be at the center, and that line will go like this. Okay, and this intersects here, so the fixed point is somewhere on the other side, but where exactly is it? Okay, so we have to see that, and let's just explore this a little bit more. Let me draw this and look at this diagram. So first of all, what I do is from this chord AM, I join this DM, and this angle is 45 degrees. I just marked it with blue. Okay, and this is subtended by AM. So AM also subtend A and M on this point. So this angle is same as that. So this is 45 degrees, and this angle is 90. So that means NM is the angle bisector of A and B. Okay, you can also join the other one. You can say this MB subtends 45 degrees here, so it will subtend 45 degrees on M and B. So this is 45 degrees. So these two angles are 45 degrees. So NM is the bisector of A and B. And now what I do is I complete this. So we have this angle bisector, and now I complete the circle. So what do you see? So if I join this one and let it meet at S. So this angle is subtended by this chord, okay, and this angle is subtended by this chord, and this whole thing is a semicircle here. So since the angles are equal, so these chords are also equal. So that means this point S, it bisects this semicircle, okay. No, so these two lengths are equal, and S is the midpoint of this semicircle ASB. So no matter where N is, okay, on this circle, NM will always bisect this angle. So NM will always pass through this point S, which is the midpoint of this semicircle. Okay, so that's the fixed point that you're looking for. So it's the midpoint of the lower semicircular arc. All right, so yeah, so the last is this. So you have this segment, you have point M1 in that, you construct the squares, find the midpoint. Find the midpoint of this square, so find the locus of this midpoint of this P and Q. So that also we can do it easily. Let's call this length as x, the whole length as a, so this is a minus x. So now we write down the coordinates of P. So it will be what? It will be x by 2, okay. And for the coordinates of Q, so the x coordinate will be x plus half of a minus x, and the y coordinate will be half of a minus x, okay. So that's this. Coordinate of Q is this, and the coordinate of midpoint will be half of this x plus 2 plus a plus x by 2, half of that, and the y coordinate will be sum of this and half of that. So okay, so we write that here and we simplify it. So what we see is that the y coordinate is always a by 4 and the x coordinate is a by 4 plus x by 2. So the midpoint will move in a horizontal line at a height a by 4 from the base, okay, and x can take values from 0 to a. So smallest value of x is 0, and then it can go till a, till this point. So this will vary from a by 4 to 3a by 4. So it's this line with a by 4 cut off here, a by 4 cut off here, and what is length is this line segment. So this is the locus. The end point is, of course, when the one of the square vanishes at this point, and the other one will take over the whole segment, okay, on both sides. So that was it, and this is the last problem. It says there are two planes P and Q, and they intersect along line P. Point A is given in plane P and C in plane Q, and they don't lie on this line P. And now you have to construct a trapezoid ABCD with AB parallel to CD, in which a circle can be inscribed, and the vertices B and D lies on the plane P and Q, respectively. Okay, so first of all, the property of isosceles trapezium with a circle. So this is isosceles trapezium. Okay, and AB is parallel to CD, so that's this, and there is circle inside. So length of these, these will be tangents from external points. So this length of blue segments will be equal, length of red segments will be equal, length of green segments will be equal, length of these two black segments will be equal. So what you can see is that AB plus CD, so that will be blue plus red plus green plus black. So that will be same as AD plus BC. So that's also, blue plus red plus green plus black. Okay. So AB plus CD equals AD plus BC. So that's one property. But for the construction, we'll use another property, which is this. So if you assume that the length of one base is x and another base is y, so the sum is x plus y. So the sum of the two slanted sides will be also, since they are equal, so it will be x plus y by 2, because the sum has to be the same. This plus this is equal to this plus this, and these two lengths are equal, so it will be x plus y by 2, x plus y by 2. And after that, we drop the perpendicular from C and D to this, and you try to calculate the value of AC prime. Okay, what do you get? So So this length is y, so length of d prime c prime will be y. So the remaining length is x minus y, and since these two lengths are symmetric and they're equal, so each part is x minus y by 2. Okay, so we write that, and after that AC primed will be AD primed plus D prime C primed. So that's x minus y by 2 plus x. So that's x plus y by 2, and which is same as this AD. So AC primed is equal to AD. Okay, so we'll use this property for the construction. All right. So yeah, so now we can have a look at this. So we okay. So now let's sort out this 3D part. So there is one plane which passes through this segment DC, and then the second plane passes through the segment AB. So both of these planes have a rotational degree of freedom. Okay, and these two lines are parallel. So if you visualize the intersection of those two planes, we'll have a line which is parallel to these two lines. Okay, so that will give you the step 1 of the construction. So you have to construct lines in both planes which is parallel to the given line P. Okay, so that's step 1. So draw L1, L2 in P and Q respectively, and which passes through A and B, and both L1 and L2 are parallel to P. Okay, so that's how it is. There is a line L1 in the first plane which is passing through A and it's parallel to P, and then the line L2 in the plane P in the plane Q, which is again parallel to P, and it passes through C. And then we look at the plane which contains both L1 and L2, which is this. And now that 3D problem is now now it has become a 2D problem here. So now we construct our trapeziums where I drop a perpendicular, and with this as radius I cut off the points on this line. Okay, with AC as radius I just draw the arc, and in general it will cut this line at 2 points. So if it cuts at 2 points, we'll get 2 trapezium. If it cuts at 1 point, then we'll have 1 trapezium, and if it does not meet this line, then the trapezium does not exist. Okay, so I'll just show you the general 2-point cut. So what we do is we call this as D1 and D2, and after that I join this AD1, AD2. And after that, all we have to do is we have to construct lines through C parallel to AD1 and AD2, this and this. So what you can also do is from C as center, you mark off the arc with same radius. You can do this and take the intersection points. Call this as B1, call this as B2. And now you have your 2 trapezium. One is this A, B1, C, D, and another one is this A, B2, C, D2. Okay, so A, B1, C, D1 and A, B2, C, D2. These are the 2 trapeziums that you get. Okay, so yeah, so that was the problems from IMO 1959. So you can see the first 3 problems were quite easy. The second 3 problems were also yeah, it was also on the easier side. I mean, if you look at from the present day perspective, but compared to the first 3 problems, it was quite difficult. Okay, so anyways, I hope you enjoyed the video and enjoy the solutions, and I'll see you. If you want, you can email me if you have anything to say, or you can write in comments. And apart from that, I will just see you next time. So take care and bye.